Jai Hind to all. I'm Dinanath Prasad. Today I'm going to discuss about the role of timer and counter which is used in a PLC. So these are the one of the topic of third unit, third unit for the subject of industrial automation and control. And why we choose this topic, because this is the present need, the need of the industry and need of the new learner who knows what is the role of timer and counter. It is basically well defined, or it is understood with the topic what is timer, what is the role of counter, but no one but very few one knows how to implement with the PLC and what is the role of controller of these devices, timer and counter. That's why I have chosen this topic from the unit number third. So coming to the introductions of timer and counter. So basically this system shows one of the industry, let's suppose any industry is having any kind of work, like you can see there is some kind of blocks picking and dropping under some places. There is various kind of robots are working. These are some kind of we can assume the industrial works are going on, and some operator is operate at some definite point. Some engineers are there, they are analyzing what going of the what are the process are going on the industry. So this is one of the example, but there is a various kind of examples are there. Through that we can explain the role of timer and counter. So what is the role of timer counter means? The process will be having different sequence, like the first one, the block will be here, then block will be there, and block will be there. Means the operations, different operations will be definitely will be going on this industry. But in every sequence, when this robot will be work function, when this block will be operated, that kind of work will be happen without the role of or knowing the role of timers, and how many blocks are counted. Let's suppose in a day 100 block or thousands block will be counted. That cannot be done with the help of with the role of counter. So there is a role of timer, and counter is very much essential in the role of automation industry. And what these people are doing, these people are basically doing the counting work. There is some display, they will be display like a role of a counter, how many blocks are made at a time. They will be displayed by the some displaying unit. There is a communications channel, there will be some protocol, through that they will be understanding. So how they implemented with the PLC is nothing but a controller. How we connect with this timer, and how to connect, what language should be given to the PLC to counting out this object. That kind of thing we'll be discussing in this lecture. So okay, fine. First of all, come to the PLC timer instructions. As I discussed, this is all about the PLC timer. So basically we having the role of what is the role of timer. First of all, we understand the term timer, then we introduce how to use timer with the PLC. Timer means we have to give some uh, process delay in process. uh, this is another role of PLC. Another role of timer, like another timer role of timer, like suppose in our home or in our room, let's suppose we automate our room, room light. So let's suppose we are entering in our room, the sensors will be sense, but I want to switch off the fan or light or any AC in our home. they will be turn on after 5 minutes after entering my in the room. That kind of operations can be done with the help of timer. Or let's suppose if we go away from the room, and as we move away from the room, within 1 minute the complete light and complete system will be shut down, switch off. Then can be operations can be done with the help of timer. So there is a very basic kind of operations can be done with the help of timer. Or if we want to use this timer operations in an industrial process, industrial things we can do for the just giving the time delay in any system. Because in an industry there is a sequence of program, sequence of operations will be going on, but all operations cannot be done at a single time. So we having giving to some delay in a system, delay in a process, that can be process can be done with the help of timer. So let's suppose this is the timer element in a ladder logic diagram. So ladder logic, we know, everyone knows, this is a very basic language, programming language out of 5 language understand in the PLC. But ladder logic is mostly used language in a PLC. Just they having two block, that is called a rail, and the where the program will be written up, that is called the rung. This is the rung and this is called the rail. So let's suppose this is the block of normally open block, and this is normally open block, let's suppose T1, and this is the output, let's suppose Q. In between them, if we put the timer operation, timer, in between that we will put the timer, means just we switch on, or we state will be changed from 0 to 1. Let's suppose initially they are in 0 state, then we change the state to be 1. The timer will be operate, then what kind of delay will be given to the system, that can feed to the this timer. Accordingly the output will be performed. So this ladder diagram is ladder operation or ladder logic programming is very easier programming to program in any PLC devices. And this timer operations we give in a system to time delay in the system. That time delay can be provided in form of millisecond, hour, in a second, or in a minute. That can be features is available with us. We can modify it according to our requirement, according to our system. So the basically there are 3 type of timers are available. uh, 3 types of timers are there. Based upon the timer, if we want some delay in a system, that there we use on delay timer. Let's suppose initially some work is already going on, but if we want to stop that process, there we use off delay timer. And another timer we generally use, that is known as retentive timer, that is represented as RTO. RTO timer is basically used when the suddenly power cut will be cut out in the system, but the counting of timer will be not stop, or the process will be started where they stop. So these are the basically 3 types of timer, and these 3 types of timer is put in the system according to the process, what kind of process will be going on. Like on delay or off delay timer we put in a very small process, but in a generally we use retentive timer in a very large process, large industrial process, where the precise measurement of the system is going on. So if we are going to discuss one by one discussion about the different timer. First one is on delay timer. What is on delay timer? As I discussed already, yeah, if we want to want to set time after after some we want to start any process or operations after some sort of time, there we use on delay timer. On delay timer is a programming instruction. This is one of the programming instruction which is used in PLC, which is used to start momentary pulse of a set period of a time. So you can see this block is the on delay timer block. You can see there is written here T on. T on represent the time on delay. Basically the role of this two block is very important in case of on delay timer, like the value of preset. What is the role of preset and accumulator? Here the preset value, or it is some block are written as in form of PV. This value will be set according to our requirement. Like we can put preset value will be 1 minute, 2 minute, 10 minute. How much time we want to delay in any process. Let's suppose we want to delay in a process of 1 minute. Let's suppose we want to delay in any process of 1 minute. So this is timer output. This is timer output. Let's suppose we give the timer input to the on delay timer. This timer input can be given with any kind of sensors, with any kind of push button. They can be any selector switches. We give input. As we give input to the system, this two block here block are shown, and that is EN block or DN block. EN stand for enable bit and DN stand for done bit. So what is the role of enable bit and done bit? So as I said earlier, when we given supply to the timer as given this state will be provided with any sensors or any push button, this enable bit will be on. There, let's suppose their stated state will be 0, or there will be a false state. Their state will be changed from 0 to 1. So in on delay timer, so as we input pulses will be getting enable bit, the function of enable bit is their state will be changed from 0 to 1. So again we having put the preset value for the 1 minute. So what is the role of accumulator? They accumulated the thing, the counting will be started like from 0, 1, 2, 3 up to 60 second. If there is a 60 second means there is a 1 minute. So as the preset value, when the preset value is equal to or greater than the accumulated value, this is the condition. When the preset value is greater than or equal to the preset value, here in our case the preset value is said to be 1 minute, means 1 minute as the counting start from 0 to 60 second means 1 minute. The preset value when equals to the accumulated value, their state will be again changed, means let's suppose the done bit will be in 0 conditions, there will be a state change to 1. Means as preset value is equal to the accumulated value, with this delay the state will be changed, done bit will be changes. So on the enable bit, as the supply given, their state will be changed, but done bit when on when preset value is greater than or equal to the accumulated value. So, this concept basically we used in a PLC devices. Okay. Now, again this block is showing of the on delay timer. There is a timer, we can set name anything. There is a preset value and accumulated value. This is the input. This is the input. So, as input is given to the system, enable bit be on. Enable bit will be on. But in this case, you can see the preset is set to be 1000. 1000 is equivalent to be 1 millisecond or 1 second. So, as we given to the input to the timer, accumulated start counting. So, the done bit is when operated, done bit is when operated when the preset value is greater than the accumulated value. When this value will be equal to or greater than, this conditions will be fulfilled. On that conditions, the done bit will be on, otherwise they will be off, and the output will be not processed. And what is the role of TT? TT stand for time timer. Time timer when operated, when done bit will be on. As done bit will be on, time timer will be on. You can see same thing with this diagram. Initially this is the run conditions, or you can say the input condition. Initially there will be not supply, there will be false conditions. As we get the supply, the state will be changed, that is true, from false to true, that is from 0 to 1. And as we get the time period, we suppose we take with time durations of 1000. This is the time duration 1000. After 1000, the system will be on delay, and the timer output bit will be changed from 0 to 1, means the done bit will be on. So, with this condition, preset value is equals to the accumulated value. So, this concept is used in a on delay timer. Similar in case of off delay timer, there as already tell you, when the system is already in a condition of running condition, but after a certain period or certain span of time, we want to switch off the system. On that conditions, the off delay timer will be operated. There will be again same block. This is the timer input. There is a preset. There will be accumulated, but difference is that this is used, this off delay timer will be used to stop up the process. In the same case, means initially they are in running conditions, mean there will be a state will be 1, but when the timer preset value when the preset value is equal to the or greater than the accumulated value, there will be a state will be changed from 1 to 0. So, this is the main difference, and as I have discussed where we use this on delay timer and the off delay timer. Let's suppose with see with this timing diagram and this block, why we put this block. Basically T 4.3 1.0 is the timer or time base is represent how we addressing to the PLC. We have to communicate with the ALC with this timer. So, we will put the addressing depending upon their input output connections. We give the address like 4.3 1.0. We in this case we set preset will be 15-second delay on the system. So, the system of delay durations is off for the 15 second. As the 15 second happens, means the preset value is equals to the accumulated value, their state will be changed from on condition to the false condition. As the condition will be get, the done bit will be on, and as well as TT block, that is time timer bit is also on. So with this, we can use what amount of initial amount we want to delay in the system, we can use on delay timer. How much time we want to stop that process, there we use off delay timer. This is very important kind of timer we can use in a automation industry. Same timer diagram, Q is represented for the output. This sort of time we want to delay in the process, so there we use on delay timer. With this sort of time we want to stop that process, there we use off delay timer. Now retentive timer. So we know in general, if any process is already in a process conditions, but what happen if there is a malfunction in the system, if there is a unpredictable supply will be goes off. On that conditions, if the power supply will be goes, then the system will be shut down. For the protecting the system to be shut down, to start the process again where the process will be stopped, on that conditions we can use the retentive timer. Like is a simple example, like a medicine factory. Let's suppose medicines compositions are going on, but let's suppose the process for the making of one process they make 10 seconds, but after 5 or 6 seconds the power will be goes off. Means if power will be goes off and the system will be stop. But if power supply is again then the process will be not continued from the 5 second or 6 second. The process will be then again started where they stop. So there is on that conditions the timer will be used like a retentive timer. So these are the for the very large kind of process, big process generally, or like an industrial kind of process, we use the retentive timer when the power will be goes off. Now comes to the timer. Timer is going on happen. Now the counter is again a very important role in a automation industry to count up. Let's suppose we want to count up how many process are going on, how many bottles are filling in a industry, how many cars are manufacturing in an industry. That kind of counting will be done. Counting will be done with the counter up. Means on that case increment, if we want to change the increment by the value of 1, there we use up counter. If we want to some rejections in a system, we want to reject some block or the reject that block or down reverse in accounting, on that conditions we use down counter. So in every state for the changing of a state from 0 to 1 or 1 to 2, for every counting their state will be changed by the adding of 1. So based upon their counting, there is 3 type of counter are used, like a one up counter for counting up, that is the increment of the value by 1. For the decrement of the value by 1, there we use down counter. If we want in any system where we want to counting up or decrement their value, there we use up down counter. So many big industries, some products are making, on the process of making, the process will be counted up regularly, but some process get defect on the system, on there we use decrement their value, there will be use down counter. So these 3 counters are very important to counting up and counting down. So first of all this up counter where we use, First of all, I will introduce about the block what is used. CU for counter up, R stand for reset, PV stand for preset value, CB stand for counter value, Q stand for output. So how they work in a up counter for the counting up or changing a state from 0 to 1, or let's suppose there will be 230 state, we change another counting, that is a toggling of switch, that is 230 to 231. How we change? So in this case, as we get the input, again in this case, if we input will be getting from the any sensors or any push button or any signal, the counter up signal will be activated, and PB is again use a preset value. Let's suppose the preset value will be 5. Let's suppose we counting the sequences on a 5 block, 5 any operations, 5 blocks will be counting in any process. So as the input will be getting, initially counter value for the first input, counter value will be showing 1. Again by getting the input they counting again 2, similarly 3, 4 and 5. So as the preset value is equals to the counter value, so means the counter will be as we said, like in this process we said the preset value will be 5. So in 5 will be, that is the preset value will be equals to the counter value. So one batch will be completed. So as 5 will be getting, the reset value will be activated, means they will showing the 0. This is showing the 0. Again next counting will be started as where we stop. Then again 1, 2, 3, 4, 5. Then reset value will be activated to 0. Then again 1, 2, 3, 4, y. So likewise this type of counting, that is the value changes from 0 to 1, the counter increment from 1 from the preset value. When the input value reaches the preset value, output turns on. The counter preset value is user defined. That value we can define, we can edit, that is dependent as per our requirement, as per our process. Similar thing is written in this line. So each pulse of the counter value, counter input, that counter input is this CU block will increase the counter value. This value is 1 by 1. Means with this batch the counting will be going on and the process will be reset will be 0. So this way the counting will be done. Let's suppose in a parking system, the parking system we can park a vehicle of 100 quantity, so there will be counter, that value is always registered in a register. Initially the one vehicle will become 1, then 2, every step there will be increment of one value. The output will be when activated, when the counter, that is vehicle, when complete vehicle will be parked on this parking lot, like in 100. If 100 vehicles will be reached, the output, that is Q will be activated, Q will be on. Then another applications of counter, that is the down counter. As I said, in up counter used for increasing or increment of the value of 1. Likewise the down counter, the value will be CD, and previously this is CU, this is CD. LD stand for load value, PB stand for preset value, CV is the counter value, Q will be the output. So when the input will be activated means given to the system is CD. Let's suppose the preset value will be 10 in quantity, anything, any process, like we want to make 10 car in a system, we want to make uh, in a parking lot there will be 10 vehicle. In a night, in a time the vehicles are going back to their places. On that process, when the this CD block will be on, the counter will be decrement, counting start in a decrement way, like a 10, 9, 8, 7, likewise up to the 0. When it is get 0, the LD value, that is the load value, will be activated, and output, that is Q, will be activated. So that's why there is a decrement of the value of Y1, the down counter will be operated. Now the up down counter, there is a, in the block of up down counter, there is a block of CU, there is a block of CD. Two switches are used, one for the up counter and another block is used for the down counter. There is a reset block. Reset block is used basically for the up, it is related to the reset value, is related to the up counter. There is a down counter block is related to the down counter. Load value is related to the down counter. PV is the preset value. We can set what amount of quantity is set in a preset value. The counter value, that is CV, is denoted either the increment value, their value will be increment from 0 to 1. If their decrement value is activated, their value will be changes from 1 to 0. So accordingly, the counter of value will be activated, output will be loaded in a registered, and display will be display. Similarly, there is a decrement value, accordingly the register will be display with respect to the down counter. So this is same thing, it is written here as I discussed in a previous slide, how the counter will be work, increment and the decrement. Accordingly, the counter up will be work and counter down value will be work. Thank you.